Question number 71 has been derived from alternating current, and slightly the question has been deviated. It says something like this: an arc lamp requires DC direct current of 10 ampere at 80 volt to function. So that is its specification in order to function. If it is connected to a 220 volt, that's RMS, 50 Hz AC supply. Now that particular arc lamp whose specification was given in DC is now being connected to AC. The series inductor needed for it to work. So it's something like this. Say, if that arc lamp, we denote it by resistance, we do it, and here is the inductor which is connected in series whose value is sought. Now here is the alternating supply which is 220 volt 50 Hz. Now since the specification of arc lamp is in DC and here we have to work in terms of RMS, so that's equivalently the same, so no such conversion would be required. But yes, it would be requiring 10 ampere. Do not care for the direction, I'm working for RMS here. Now in that situation the voltage here has to be 80 volt. Now let's try to see how much would be the RMS voltage across the inductor. The RMS supply here is 220. You know, the RMS values are added graphically, not algebraically. So it's something like this: 220 square would be 80 square plus VL square. That's the first equation. The reason being is this is RMS and these two RMS are spaced apart in phase by 90 degrees. So this sort of addition is required. And what is VL? VL would be I, which is 10 times XL, that's 2 pi F is the frequency into L. Now here are these two equations. A small amount of calculation is of course required. On doing so, you would get the value of inductance to be 0.065 Henry, which gives third option. So with that, we'll completed question number 71 as well. Let's move to question number 72. Question number 72 is another directly formula based question, and that has been drawn from the topic wave and specifically standing wave in organ pipes. It says a pipe open at both ends has a fundamental frequency of F in air. So this is the situation, and if I would like to show it through the process during the fundamental vibration, this is the situation. This being the displacement antinode, and when it comes for pressure, you know, it's a pressure node. Now the pipe is dipped vertically in water so that half of it is submerged. It means now it would be a closed organ pipe, closed at one end, and length is L by 2. So we have to calculate the fundamental vibration frequency here. So out here you could see this is lambda by 4, lambda by 4. So L would be equals to lambda by 2. In other words, lambda is 2L. And here this is lambda by 4. So lambda by 4 is L by 2 here. And again lambda comes out to be 2L. Now you could easily see, since the wavelengths in both the situation is same and the vibration is in air, the velocity of sound also is same. So that clearly indicates the frequency in the second case would also be same. So it's straightforward. The fundamental frequency in this case would also be F, because F is in the first case. So that gives us correct option as option number 3. Together with this, we end question number 72. Now we'll move to question number 73. All right, question number 73 is quite a nice question, and lots of thought process would be involved here. It says the box of a pinhole camera of length L. So let me make a pinhole camera of length L has a hole of radius A. Of course, this radius is A. It is assumed that when the hole is illuminated by a parallel beam of light of wavelength lambda, the spread of the spot is sum of geometrical spread plus diffraction. So something like this. Now the spot would then have its minimum size when the condition is required. So here see, this is the regular ray optics part and here is that spreading. So if I call this as theta, this particular distance quite obviously would be equals to L times theta, and that would be L lambda by E by the simple use of diffraction formula. And this is the radius, which is A. Now the size of the spot here would be, let me say that the size is B, what has been said is A plus